Yeah, I think we can start now. Robert, please, you have the floor to start.
Okay, thank you, everybody. Thanks for attending. My name is Robert Sprunk. I also work for the Energy Lab Foundation, and I would like to give this talk today on the ideas for the EV integration and interoperability. First, I would like to start with the agenda. So in the beginning, I just want to give a bit of motivation about the energy transition and EVs, of course, how this fits together and how we want to accelerate this using technology. Then it will take some looks into the different building blocks that are also already in the title here, namely digital identity in general, then the approach using public blockchain, and then also e-roaming in the open charging network. And in the next chapter, we will then use these building blocks to take a deeper look on how the technology can be used, namely DIDs, decentralized identifiers, and VCs, verifiable credentials, and how all of this together then can be used for an integration and interoperability. And lastly, then I would also like to give you some more resources if you are more interested to learn more and start the Q&A session. Yes, and that being said, I am at the Energy Web Foundation for a few years now, mainly working on e-mobility, but also other asset connections. So not just vehicles, but for example, also PVs, heat pumps, and so on. So when we started Energy Web, or the reason why we actually started was that we noticed that customer spending, especially for clean energy assets, is rising. And at some point, it will eclipse what traditional utilities are spending on assets. And of course, customers do not want to spend their money twice. So the assets that the customers already own, they are definitely the future of the energy sector and also key to make the energy transition happen in time. So there are different types of asset classes, for example, stationary batteries, smart AC systems, but of course also electric vehicles and charging infrastructure, because they are, from an energy perspective, yeah, like large battery on wheels. I think you heard this term probably before. And this is also something that we are tackling with the open charging network that connects the EVs and the charging stations together and makes them available to the grid. But we also noticed that these assets, at least today, they're not really always properly integrated and not always easily accessible. So in order to make this transition from a centralized energy system that is rather top down and hierarchical and just is built around the operation of a small number of power plants, we needed to find a way to make the transition into a more decentralized system that is, of course, still as secure and stable as today's energy system, but also accommodates all of the smaller energy resources that are available in the market. And that's why we launched Energy Web, mainly to help grid operators transform the way they run energy markets, and with always the goal in mind to decarbonize the whole energy grid. So with the mission to deploy an open source decentralized operating system in support of a lower energy future, we created a non-profit foundation that is easily in the intersection between energy, digitalization, and blockchain, and working across the whole globe from different offices. We do this, of course, not alone, but we have a large membership. Many companies are part of our foundation. They work together, they use our technology, they contribute their own knowledge and their own requirements. And together we are building this decentralized operating system and the vision of a cleaner future. And on a bit more a detailed level, we of course have several specific problems to solve here. Regulators also for high-level engagement are quite important, and they still need to play a role. So I think when we talk about decentralization, we are mainly talking about one digital way to make this happen, and still, of course, adhering to all the regulations that are in place and allowing grid operators a more smooth way to run their markets and programs. And in order to allow this, we noticed quite early that we would need to establish permissions, relationships, authorizations, and so on between many different parties. So we have a shared state that needs to be able to be validated by all the players independently. so that they can establish trust where initially there's no trust. And that's, of course, not just true for entities like companies and individuals, but also for the assets themselves, like EVs. And with that, I would now like to start talking a bit more about the individual building blocks that we have, just so everybody is on a common ground, and we can then have a later nice discussion around these topics. So just a quick intro to what identity means. Identity is basically comprised of two different artifacts, and that is usually an identifier paired with several different attributes. So if you have your ID card, your passport, it may have a number, and this number you can mention as being your identifier. And then there are several different attributes stored in this passport as well. And together, this can form an identity. But of course, the passport alone is not your whole identity. Obviously, you have many more attributes that are not stored there. But from a certain use case perspective, this might be sufficient. And this identity can then also link to other identities. For example, you buy something and then you have a purchase receipt of an electric vehicle, which refers back to you as the owner, which again has its own identity. And this link can then also be signed by a then centralized or also decentralized organization that proves that you are the owner of the specific vehicle or that you are allowed to use it. The problem that we have usually is when you want to prove that you indeed are allowed to do something, or that you are indeed who you say you are, is that somebody wants to prove your identity. And quite straightforward is somebody asks you directly for your document and checks the signature on this document. But this also, especially in the digital world, comes with some problems, because first you would of course need to know how can you contact the other person. The other person needs to be there and also for you to reach in this point of time. And then of course also the other person could still present a document that is valid, but maybe has been superseded by a more recent version of the same document. And this would basically require the other person to list all of their current and previous identity documents, which is a more difficult task to achieve. And the solution for these problems would be a data structure that is publicly available and doesn't forget. And that's how we arrive at the conclusion that the public blockchain for interoperability in the whole energy system could be a quite nice solution to, basically tackle these problems, because it's not under the control of any single entity, and it's impossible to change history, at least almost impossible. And it is publicly writable. So in this example, Alice could write some signatures to the blockchain, and somebody else, Bob, can read from it and is then able to verify Alice's identity. Now we are at the point where we can start thinking about several different use cases once we have this groundwork done. So we can, for example, build a smart green charging use case. We can also build battery tracking and recycling use cases, or flexibility for the grid, where vehicles or charge points react dynamically to the demand in the grid. And we can also build a peer-to-peer e-roaming network, because we can now establish trust and identities across company borders. And at Energy Web, we offer several different toolkits to implement these use cases. And these are toolkits, these are not products. So if you're interested in working with any of these, then also please contact us. We are, of course, always happy for more companies that are rolling this out in production, and that are also then helping us to further develop the fit of these development kits. Mainly for like green proofs and green charging, we have Origin. For tracking, we have Trace. For flexibility, Flex, and then for charging and e-roaming, we have the Open Charging Network. So let's take a deeper look at Open Charging Network, because today EVs are at the center of our focus. So the Open Charging Network is a toolkit and framework that allows to build decentralized roaming and grid integration services. And at its core, it connects chargeback operators with e-mobility service providers and grid operators. and then also extends to vehicles and charge points directly, as we will see in the later slides, as well as fleet owners and EV drivers. Because we have this decentralized identity approach, it does basically scale with the number of devices naturally, and it's quite easy to handle at scale as well. And the network itself is completely free to use and is currently implementing the LCPI 2.2 standard for connection of the backends. And it's integrated with different CPOs and EMSPs that can then use it to offer lower charging fees because the network itself is free to use, and also allow an improved user experience because there are no artificial boundaries to the network. Then the OCN itself can also be extended by several different apps. Then also coming back to the use cases we had just seen in the previous slide, which can request from a specific vehicle or charge point, get its data, and offer it to third parties. On a high level, this is how the network could look like. So we have several different vehicles, we have charge points, we have CPOs, we have EMSPs, and they can all connect to their own or also to somebody else's OCN node. And the OCN nodes will then take care of the routing within the network so that you're always able to contact the other person. And whenever somebody new joins the network, they can choose to either pay somebody else to run a node for them, or they can run their own node. And that's also basically all the costs that will occur. Then also to establish identities, there is a registry inside the network where people can, companies can register themselves and make themselves known. And all the messages are signed so that in the decentralized network, we can still be sure that they have not been altered by anybody else. But of course, this is much more than just roaming. There are several different services that can be built on top. For example, clearing payment connections, then integration services for green charging, reporting functionalities. All of these services can be built on top of the network. And all of this is then also up to companies like our members and others to commercialize, as we are just building the foundation and the building blocks behind it. So I think with that being said, we can then take a look also on this level of extension. How would it be possible to extend the network with several different services? And the interface is called the OCN service interface. And it allows, especially from the grid perspective. So for example, our member ELIA group uses it to get visibility on charge sessions and use this data on a transmission grid operator to allow for a more sustainable grid operation. And also for them, again, the data is free to use. And since the network itself is run by the community. But of course, it's still able to offer to have the actual service itself, a paid service. That's of course up to the service provider to choose what they want to do. And next to these grid services and green charging, is of course always possible to imagine any other use case that can be built on top of this kind of decentralized infrastructure and then offer additional services. And to recap, yes, the network itself is completely free to use. There are zero network or roaming fees. There's very low operating costs to run the OCN node itself, but also hosted nodes are available. And one way to also get an already existing node is to leverage the decentralized service level agreement, where it's possible to stake a certain amount of tokens and in return get network services. So instead of actually paying, they are just staked, which also means whenever somebody decides to leave the network, you would get the full amount of tokens back, and it's as if you never paid anything. Then on a settlement layer, the OCN itself is completely payment method agnostic. So it could be basically any kind of currency, any kind of rate, but of course also settlement in real time using tokens is possible. And then on top of this, if the payment flow is usually directly from the user into the hand of the CPO, we can avoid cross-border difficulties arising from tax complications if somebody's EMSP would be in a different country than the home country that they are currently charging in. And if you're interested in connecting or offering a service node on the OCN, then it's usually quite straightforward, especially for development. Also, free hosted nodes are available. The permissions are, of course, still important because you would still need to get whitelisted from the individual CPO or EMSPs to offer a service. And then customers are able to use the application that's built on top of this OCN. So now we have several different building blocks in our hands. We have digital identities. We also have a public blockchain, and we have a network that is built with roaming in mind. And now we'll take a deeper look into how this can be built together technically. So a quick recap on identity. So identity, as being comprised of identifiers and attributes, are represented in the W3C standard, namely called decentralized identifiers and verifiable credentials. So the identifier is the DID, and several different attributes are verifiable credentials. And the goal behind this is that we can enable authentication and authorization across company borders. Of course, the IDs are not the only way to address this. So if you're more interested in this topic, I can highly recommend this paper, Self-Sovereign Identity for IoT Environments, where I also took this nice comparison from. So it starts also with PGP, then also a traditional PKI or certificate system. At least for me, and I've worked some time in this field, I have not been aware of this attribute certificate that X509 offers to attach additional attributes to a public key certificate. And on the DID side, so for self-sovereign identity, we have the DID, or more specifically the DID document, and the verifiable credential. And there are several benefits to this technology over X509 or other systems, also being one, the more flexible approach that makes it a better fit for several different use cases. So I can really recommend this paper if you want to know more about this in depth. If you continue looking at self-sovereign identity and the DIDs, what they can mean, it could be any identifier basically that you can think of. It could be an email address, it could be a username, it could be an passport ID. And then we have several different VCs that are attached to this, just like birth dates, the height, but maybe also a whole string of data like a location history. And when we have these things at hand, we can then build a self-sovereign model. So just for comparison here, if you look at the left side, we have a centralized, more federated model. That's similar to when you're in the web and you're using sign in with Google, sign in with Apple, or sign in with Facebook. Then the user has an account with already one existing site, and you are using it to sign into some other site. So this means that the data is directly exchanged between these two sites. And at least technically speaking, they could also exchange this data completely without the user's consent. However, in a self-sovereign model, you are getting a credential directly from an issuer, and you're able to show it yourself to another company that you want to prove your identity to. And these two do not need to be able to contact each other directly. And in order to make this a bit more easy and structured, usually there are also registries involved where users then can anchor their identity. But also this is not absolutely required. So this question is quite common also when it comes to DIDs. Is blockchain really required for DIDs? And the short answer is no, it's not required. However, it has a lot of good benefits that it brings, especially for DIDs in the public use case. But there's also a very specific DID method called DID peer, which is specifically for peer authentication without any data layer between. So this is also something, of course, to keep in mind when building these kind of systems, that blockchain is never just one answer for all the problems. Actually, quite the opposite. It's just the answer to a very specific question. So if we don't need this, we could build it without. But I think in our case, where we're talking about integrating whole two different industries between electric mobility and the grid, blockchain provides really, really good values. So if we talk a bit more about the verifiable credentials themselves, because they are really the, I think, most interesting part. This is where the data is stored. And of course, they also stay private. So this is never on chain and never publicly available unless directly chosen to make it public. And we have many different individual components of this credential. So each credential itself has its own identifier. There might be some metadata, like an expiration date. And then there are several different claims. So this is what you later want to prove. And the whole credential is then signed by an issuer. And if we then take a look at how this flow would look like, so let's say I would like to prove that my name is indeed Robert, I work for Energy Web, then there might be somebody here at my company that can prove that I work indeed here. So I could ask them to issue a credential to me. After this request of the credential, they would issue the credential to me. And this signature can be stored in a public ledger together with my DID. But the credential itself is still stored in my wallet. So if somebody has only access to the public network, but I am not cooperating or proving anything, they would not be able to learn anything. But if I now want to prove to maybe a third party that I'm an NHIP employee, I'm able to present my proof, and the signature can then be verified from the public blockchain. And since the public blockchain is available to everybody, it's quite easy to read and also to verify the signature, but it's not possible for me to single-handedly change it or change the history there. And what we then see, of course, in this case is that we need to establish trust between, in this case, the verifier and the issuer. And the credential itself also is something that is usually stored in rest, so it's stored in my wallet. But if I want to make it available to a verifier, I have to present it. So this presentation is then also called the verifiable presentation. And I need to cooperate in order to create the verified presentation. But also the verifier needs to be actively involved in order to avoid replay attacks. So they would send a challenge to me, which I then include into my response of the data itself. And it can be even more extended by using zero-knowledge proofs so that I can prove certain properties without revealing the property itself. So a common example is I want to prove that I'm more than 80 years old without proving my actual age. But my passport might store my birth date. But revealing the whole birth date might be too much information. If somebody just asks the question, are you above 18? And this is exactly the kind of answers that zero-knowledge proofs can provide. And they can be directly integrated and are also already directly integrated in the verified presentation flow. But what we still have not solved at this point is how does the verifier trust the issuer? Because in a decentralized world, this would mean that each company has to have a trust relationship with every other company, which of course would not really scale. And that's where the governance frameworks come into play. So the governance frameworks, they set some rules on who is allowed to issue which kind of roles or proofs and how they can be verified. And this itself can then also be published, for example, on the blockchain so that everybody is able to at least examine the governance framework and the rules that exist in the governance architecture. And whenever somebody is then verifying the credentials, they will be able to verify the credential in itself. Like, for example, is the signature correct or has it been changed? And if it is correct, they can also check if the signature is actually issued by somebody who is allowed to issue these kind of signatures. But as always, this governance is something, it's an offer, it's available, but also it's not necessary for each individual use case. Because if they verify an issue or if they can establish trust directly, then the governance might not be needed in that case. So if we now come back to e-roaming and how this can work together. So traditionally, when an EMSP and the CPO want to talk to each other, they have agreed on a certain protocol. It could be OCPI, it could be another roaming protocol. Then they want to exchange information about their users, their charge points. But the users and charge points themselves are usually completely under the control of each EMSP and CPO. So technically speaking, if an EMSP wants to unlock a certain charge point, they could just do that. They could just send the roaming message and the CPO would have no way of knowing if it actually originated from a real user request or just from a maybe malfunction of the EMSP backend. And in a similar way, also, of course, the charge point routing is completely up to the CPO system. So if they route the unlock request to a different charge point, then then there's nothing much the user can do about it. And initially, the LCN just implemented a very similar protocol, but we were able to add DIDs now to this. So each component in the system, including the companies and the devices and users, they can now have a wallet where they can have their DIDs, and they can also have verifiable credentials that prove certain attributes about them. And it could be, maybe it's the battery size of the vehicle, maybe it's the maximum charging power of the charge point. And with this proofs together, we are then able to allow the grid operators to retrieve the information in real time, but actually have trust up to device level. And this allows us then to build several different use cases on a grid level and also at a scale that if a centralized system would not be possible easily or directly. Of course, we still have the question, who is actually able to say which size does a certain battery in a certain vehicle have. So that's why we're also involving vehicle OEMs to issue the information as a verifiable credential to the car on the same side, of course, with the charge points. And then if we take this example a bit further, it could look something like this. Because if each device is actually capable of holding its own keys and its own verifiable credentials, then they can also start talking through a decentralized asset hub directly to each other. And then it becomes actually a fully trusted end-to-end encrypted system where different asset classes, and that's beyond just EVs and charge points, but it could also be photovoltaic, heat pumps, and so on, then they're all able to connect to an asset hub through their protocols that already exist in the industry. And then the grid, on the grid side, we are able to leverage all of the different asset classes through through basically unified protocols and unified interfaces. And the grid does not really have to have knowledge about the lower level protocols or which types of assets are behind. The grid is able to offer green charging solutions, green energy solutions. The grid is able to offer smart solutions or flexibility. And that, of course, goes across different asset types and classes. And the e-roaming aspect itself just becomes one of the features that this decentralized application can implement then. And the very first step that we took together with our members, Elia Group and BMW, were demonstrated sometime at the end of last year, where we issued a digital passport to an electric vehicle and used the digital passport to charge at the public charge station. Allowing us to unlock the charge station and start the charging process directly by proving the vehicle's identity and verifying it on the grid side by Elia. So with that, I would then like to come to the end and also open the round for some of your questions. But before we come there, of course, whenever we talk about this much technology and whenever we talk about trust, I think it's extremely important to point out that everything that's happening, all the processes, they need to be independently verifiable. We can also not let ourselves be subject to lock-in effects. That's why we are also choosing to make the whole stack open source, free to use under open source licenses, which allows each company and each individual to verify the functionalities. It also allows for smooth collaboration because we don't need to have the NDAs for disclosing the inner workings of the software. It also comes with a lot of experience in the introduction of open source in the industry, also including the license compliance, including all the dependency of the source code. And also, I think another quite nice effort and approach is the public money, public code campaign. So whenever somebody receives public funding through a public fund, then the resulting code is also available to the public. And I think we are also noticing in the EU, European Union, that this is a direction that is going in more and more. And lastly, we also create digital sovereignty for the individual countries because they do not need to depend on another country's infrastructure that they might not be able to verify at its deepest level. And we are mitigating lock-in effects from one, technology itself, because of course the building blocks are replaceable, but also from certain software suppliers. And with that being said, of course, the questions usually at this point is then how is this financed? How is it possible to build this software open source at this scale? And our answer is that we are, of course, a nonprofit foundation. We are paid for by our members. Memberships also come with several different benefits. One is that members are eligible to host a validator node on the EW chain. We will, of course, also help our members to achieve their goals. They are able to shape our roadmap according to their own requirements and use cases. Members get their own Slack channel inside our company Slack where they can directly get their questions answered. There are also forums and regional meetings. Then there is some more training content for their employees of members. And of course, we will also offer business support when any member is looking for partnerships in the energy or blockchain space. And before coming to the end, I would also like to give you some more resources if you have become interested and you would like to know more. There is some source code here, there is some documentation and also more high-level information around case studies and press releases. And if you are then interested in the OCN specifically as a developer, we actually also offer a free community Slack channel for implementation of everything related to the OCN. So if you're interested in this specifically, then please feel also free to reach out to me. And with that, I would like to thank